A sports car starts from rest, accelerates at a constant rate a, then immediately slams on the brakes, decelerating at a constant rate of 4a until it completely comes to a stop. What fraction of the total distance was covered while the car was braking? So it might look something like this, where it started there, accelerated until here, and then came to a stop here. So we know that the initial velocity is 0 meters per second. Here is the maximum velocity, and here is the final velocity, which we also know is 0 meters per second because the car comes to a rest. So this seems like a problem where we should use kinematics. And we can think about considering these two parts separately and then find a variable that is in common, and then which is the displacement. Let me just show you. So we have the initial velocity for this first part. We have the final velocity, which would be Vmax. So I'll just write it like that. We have Vmax, and we want the displacement, something to do with the displacement. So that'll also probably be in our equation. And we also have the acceleration, because we're given that it accelerates at a constant rate of 4a. So this fourth kinematic equation is just right for this. So substituting our values, the final velocity in this first part is Vmax. So I'll just label this delta x1 and this as delta x2. So we have Vmax squared is equal to V naught squared is just 0. So V naught squared plus 2 times the acceleration times the displacement, which in this case is delta x1. Now we consider this part. We can just use the same equation. So we know that in this case the final velocity is actually 0 meters per second. So we have that 0 is equal to V naught is actually Vmax. So Vmax squared plus, and we have 2 and not 4a, but negative 4a since it's decelerating. So negative 4a times delta x2. Subtract Vmax squared from both sides and simplify this. And we get this. Now, if we multiply both sides by -1, we get V max squared is equal to 8a delta x2. And Vmax squared is the same for both of them since Vmax is a shared term. So we can set these two things equal to each other. So 2a times delta x1 is equal to 8a times delta x2. And a is the same for both of them, like the value of a, since this is just 4a and this is a. Are still in terms of the same variable. So these cancel out, and we can write this as delta x1 is equal to, just divide by 2, 4 times delta x2. So we can just rewrite delta x1 as 4 times delta and delta x2. And this means the fraction of the displacement that was spent decelerating is delta x2 over 2 over 4 delta x2 plus delta x2, since we want fraction is just this deceleration portion over total portion. And this is just equal to 1/5. So the portion of the distance that was spent decelerating is 1/5 of it.